All right. So now let's bring some symbols in, a related problem. You are given a set that consists of n elements, and you're supposed to take those n elements and put them in a sequence. That is, to order them. Any possible ordering of those elements is called a permutation. So, for example, if we have the set 1, 2, 3, 4, a possible permutation is the list 2, 1, the 3, 4, 1. That's one possible permutation. And there's lots of possible permutations. Of course, the question is how many are there? Okay, let's think about building this permutation by choosing one at a time which of these elements goes into each one of these slots. How many choices for the number that goes into the first slot or the element? Well, we can choose any one of the available elements, so we have n choices. Having used up, let's say this element goes here. Having used up that element, we're left with n minus 1 elements, and we can pick any one of these and bring it into the second slot. So here we have n choices. Here we're going to have n minus 1 choices. Then how many we put there, we'll have n minus 2 choices. And you go down until the end. What happens at this point when you are to pick the last element? Well, you've used n minus 1 of them. There's only one left in your bag. You're forced to use that one. So at the last stage, you're going to have only one choice. So basically, the number of possible permutations is the product of all integers from n down to 1 or from 1 up to n. And there's a symbol that we use for this number. It's called n factorial. So n factorial is the number of permutations of n objects, the number of ways that you can order n objects that are given to you. Now, a different question. We have n elements. Let's say the elements are 1, 2, 3, up to n. And it's a set. And we want to create a subset. How many possible subsets are there? So picking a subset means looking at each one of the elements and deciding whether you're going to put it in the subset or not. For example, I could choose to put 1 in, but 2, I'm not putting it in. 3, I'm not putting it in. 4, I'm putting it in, and so on. So, and that's how you create a subset. You look at each one of the elements and you say, okay, I'm going to put it in the subset or I'm not going to put it. So think of these as consisting of stages. At each stage, you look at one element and you make a binary decision. Do I put it in the subset or not? So therefore, how many subsets are there? Well, I have two choices for the first element. Am I going to put it in the subset or not? I have two choices for the next element, and so on. For all elements, we have, for each one of the elements, we have two choices. So the overall number of choices is 2 to the power n. So, conclusion, the number of subsets of an n element set is 2 to the n. So in particular, if we take n equal to 1, let's check that our answer makes sense. If we have n equal to 1, how many subsets does it have? So we're dealing with the set of just 1. What are the subsets? One subset is this one. Do we have other subsets of the one element set? Yes, we have the empty set. That's a second one. These are the two possible subsets of this particular set. So two subsets when n is equal to 1, that checks the answer. All right.